Thanks for spending this time with us. Before we begin, if you find these long, quiet explorations helpful, you're welcome to like the video or subscribe for more journeys like this one. It helps others find the channel, and it allows this space to continue growing slowly, the way these ideas do. If you'd like, you can also share in the comments the first moment you remember becoming aware of time moving slowly. Whether it was a long summer afternoon, a quiet night that seemed to stretch on, or a moment when the world felt briefly unhurried. There's no need to explain it fully. Just the memory itself is enough. Tonight, we're exploring time, not as something that rushes forward, but as something that unfolds patiently across the universe. In everyday life, time feels constant and insistent. Clocks move, schedules fill. Days seem to pass faster the longer we live. Change feels continuous, sometimes even urgent, as though everything is always moving towards something else. But when we step away from human scale, time begins to look very different. Across the universe, change is rarely fast. It is gradual, distributed, and often so slow that it feels indistinguishable from stillness. Galaxies take billions of years to evolve. Stars spend most of their lives appearing unchanged. Even the expansion of the universe itself unfolds at a pace that resists intuition. This raises a quiet question. If time is always moving forward, why does so much of the universe seem to linger? Why do structures last for such immense spans? Why does change on cosmic scales feel more like drifting than motion? To explore this, we'll gently step away from how time feels from the inside and begin looking at how time behaves from the outside through the lens of modern physics. Time, in physics, is not experienced. It is measured. It does not hurry. It does not slow down. It simply allows processes to unfold according to the rules that govern them. What gives time its character is not its speed, but what happens within it. On Earth, change feels rapid because the systems we live inside are small and energetic. Weather shifts. Biological processes move quickly. Human lives are short relative to planetary and stellar cycles. But the universe is not built around biology. It is built around gravity, energy, and space. Forces that operate most efficiently over long durations. When matter is spread thinly, change slows. When systems reach balance, change becomes subtle. When energy gradients soften, motion becomes less dramatic. The universe is very good at finding these conditions. This is why time, on cosmic scales, often feels quiet. A star can shine steadily for billions of years without noticeably changing its appearance. From one century to the next, it looks the same. From 1 million years to the next, the difference is still slight. Only when we widen our perspective far enough does time reveal its true shape. When we talk about time, it's easy to imagine it as something active, something that moves, something that pushes events forward, something that causes change. In everyday language, we say that time passes, that it flows, that it runs out. These phrases are useful, but they quietly suggest something misleading. In physics, time does not act on the universe. It does not push. It does not pull. It does not cause things to happen. Time is not a force. Instead, time is a measure, a framework we use to describe how change unfolds. This distinction is subtle, but important. Atoms vibrate, particles interact, energy shifts from one form to another. Gravity reshapes structure. Time does not initiate these processes, it orders them. It allows us to say that one event happened before another, that one process lasted longer than another, that change occurred gradually rather than suddenly. In physics, time appears as a coordinate, not an agent, a way of locating events within a broader structure. This is why clocks matter so much. A clock is not capturing time itself. It is counting a repeated physical process, a swinging pendulum, a vibrating atom, an oscillating crystal. We define time by counting these repetitions. And because all clocks are physical systems, all measurements of time are local. There is no universal clock outside the universe. Every observer measures time using processes available where they are, under the conditions they experience. This has profound consequences. Time does not pass at the same rate for everyone. Motion affects time. Gravity affects time. Not because time changes its nature, but because the physical processes used to measure it are affected by these conditions. A fast-moving clock ticks differently than a stationary one. A clock deep in a gravitational field ticks differently than one far away from massive objects. These effects are subtle in daily life, but they are real and measurable. Time is not separate from space. It is woven into the same structure. And once we see time this way, many familiar assumptions begin to soften. When we talk about time, it's easy to imagine it as something active, something that moves, something that pushes events forward, something that causes change. In everyday language, we say that time passes, that it flows, that it runs out. These phrases are useful, but they quietly suggest something misleading. In physics, time does not act on the universe. It does not push. It does not pull. It does not cause things to happen. Time is not a force. Instead, time is a measure, a framework we use to describe how change unfolds. This distinction is subtle, but important. Atoms vibrate, particles interact, energy shifts from one form to another. Gravity reshapes structure. Time does not initiate these processes, it orders them. It allows us to say that one event happened before another, that one process lasted longer than another, that change occurred gradually rather than suddenly. In physics, time appears as a coordinate, not an agent, a way of locating events within a broader structure. This is why clocks matter so much. A clock is not capturing time itself. It is counting a repeated physical process, a swinging pendulum, a vibrating atom, an oscillating crystal. We define time by counting these repetitions. And because all clocks are physical systems, all measurements of time are local. There is no universal clock outside the universe. Every observer measures time using processes available where they are, under the conditions they experience. This has profound consequences. Time does not pass at the same rate for everyone. Motion affects time. Gravity affects time. Not because time changes its nature, but because the physical processes used to measure it are affected by these conditions. A fast-moving clock ticks differently than a stationary one. A clock deep in a gravitational field ticks differently than one far away from massive objects. These effects are subtle in daily life, but they are real and measurable. Time is not separate from space. It is woven into the same structure, and once we see time this way, many familiar assumptions begin to soften. Once time is understood as a measure rather than a force, a new question quietly takes shape. If time is simply a way of ordering change, why does that order feel so one-sided? Why do we remember the past, but not the future? Why do systems appear to move from order to disorder, from concentration to dispersion, from structure to softness? In physics, this question is known as the arrow of time. And unlike many questions about time, its answer does not come from clocks or equations of motion. It comes from statistics. On microscopic scales, the laws of physics are largely indifferent to direction. The equations that describe particle interactions work just as well forward as backward. Nothing in those equations demands a preferred direction. And yet, at large scales, direction emerges. Ice melts, gas spreads, energy disperses. We never observe these processes spontaneously reversing. This asymmetry does not arise because time itself points forward. It arises because systems tend to move toward more probable states. When energy is concentrated, there are relatively few ways it can be arranged. When energy is spread out, there are vastly more. Nature does not choose outcomes. It explores possibilities, and overwhelmingly, there are more ways for systems to be disordered than ordered. This tendency is captured in a concept called entropy. Entropy is often described as disorder, but it is more accurately a measure of how many configurations a system can have. A low entropy state is special. A high entropy state is common. As time progresses, systems move from special arrangements to common ones, not because they must, but because they almost always do. This is what gives time its apparent direction. Not a push, but a preference. And this preference does not belong to time itself. It belongs to probability. The universe began in an extraordinarily low entropy state, a condition of remarkable uniformity and order. From that starting point, there were countless ways for things to change, and very few ways for them to remain the same. So change unfolded, structure formed, energy flowed, gradients softened, and with that unfolding, time acquired a direction we could recognize. The arrow of time is not something imposed on the universe. It is something revealed by how the universe began. As systems evolve, they move toward states that are easier to maintain because they require less coordination. This is why the future feels open and the past feels fixed. The past consists of fewer configurations. The future contains many. And as time advances, systems naturally drift toward that abundance. This does not mean that everything dissolves into chaos. It means that stability often takes the form of uniformity rather than precision. Stars demonstrate this beautifully. They begin as concentrated clouds, ignite into structured balance, and eventually settle into long-lasting states. That change, very little. The direction of time does not force this path. It allows it. Time is not a river carrying objects along. It is the record of how likely arrangements replace unlikely ones. And once we see this, the arrow of time begins to feel less mysterious. Not something added to reality, but something that emerges from it. As we move outward from everyday experience, time does not just acquire direction, it acquires flexibility. At human scales, time feels uniform. 1 second follows another with dependable regularity. But the universe does not treat time as rigid. It allows time to stretch. According to modern physics, time passes at different rates, depending on motion and gravity. This is not an illusion and not a trick of perception. It is a structural feature of reality. When an object moves quickly through space, time passes more slowly for it, relative to a stationary observer. When an object exists in a strong gravitational field, time passes more slowly. Compared to a region of weaker gravity, these effects are not dramatic in daily life, but they are measurable. Satellites orbiting Earth experience time differently than clocks on the ground. Particles moving near the speed of light experience time so slowly that entire lifetimes can pass elsewhere, while almost nothing passes for them. This does not mean time is breaking. It means time is responding to the structure of space-time. Space and time are not separate entities. They form a single fabric. Motion through space affects motion through time. Gravity curves this fabric, and time follows that curvature. From this perspective, time is not universal. It is local. Each observer carries their own timeline, shaped by their motion and surroundings. This does not lead to contradiction, because the underlying structure remains consistent. Events still relate to one another in predictable ways. What changes is how long those relations take to unfold. At cosmic scales, this flexibility allows time to slow almost to stillness. Near massive objects, time stretches. Across vast, diffuse regions of space, change unfolds gently. The universe does not hurry itself. It allows different regions to evolve at different paces without breaking coherence. This is why the cosmos can be dynamic and calm at the same time. Explosions occur locally. Evolution proceeds gradually elsewhere, and across the whole, time accommodates both. When we look at the universe through this lens, the feeling that time is rushing begins to soften. Time is not accelerating toward an end. It is adapting to structure. It stretches where gravity is strong. It relaxes where space is wide and thin. And because most of the universe is vast and diffuse, most of time unfolds slowly. This is why cosmic history feels quiet when viewed broadly. The universe spends far more time enduring than transforming, and this endurance is not accidental. It is built into the structure of space-time itself. Up to this point, time may still feel like an idea, something discussed, described, measured, and framed, but not fully inhabited. That's natural. Time is one of the few concepts that exists everywhere, yet resists being directly observed. We never see time itself. We only see what changes. A shadow shifts across the ground. A star exhausts its fuel. A signal arrives later than expected. Time reveals itself indirectly through differences between moments. But as we slow down enough, those differences begin to feel less urgent. And in that slowing, time stops behaving like a background and starts behaving like a structure. In modern physics, time is not an invisible river carrying events along. It is part of the architecture of reality. Events do not happen in time, so much as they are positioned within it. Each event has a location, not just in space, but in space-time. This shift matters because once time is treated as structure, it no longer needs to move. Structures don't flow, they hold. A mountain doesn't rush forward. A valley doesn't hurry toward the sea. They persist. Time, at large scales, behaves the same way. It provides relationships between events without needing to announce itself. This is why the universe can feel so calm. Despite containing constant motion, particles move, fields fluctuate, energy redistributes, but the framework that allows these things to occur does not tremble with them. It remains. This idea becomes clearer when we consider how little actually changes. Across most of the universe, galaxies maintain their shapes. For billions of years, stars remain in steady phases, longer than life has existed on Earth. Even the expansion of the universe itself unfolds without drama. No sound, no acceleration we can feel, no sensation of movement, just distance increasing quietly between distant regions. This is not what we usually imagine. When we think of time, we imagine ticking, progression, a sense of being carried forward. But those sensations belong to biology. They arise because living systems depend on change. Metabolism requires gradients. Memory requires difference. Consciousness requires sequence. Remove those needs, and time becomes something else entirely. It becomes permission. Permission for processes to unfold at whatever pace the physical conditions allow. And most physical conditions do not favor speed. They favor balance. This is why, when physicists describe the universe at its largest scales, they rarely talk about urgency. They talk about stability, equilibrium, long-term behavior. They model systems not over years or centuries, but over billions of years. And when they do, time stops feeling like something that is passing. It starts feeling like something that is simply there. This perspective changes how we interpret motion itself. A process that feels slow to us may be unfolding at its natural pace. A process that feels fast may be the exception rather than the rule. Time does not judge these differences, it accommodates them. And once we accept this, the question of time's speed begins to dissolve. Time does not move quickly or slowly. Processes do. Time simply allows their durations to be compared. This is why two observers can disagree about how much time has passed. Without contradiction, they are not disagreeing about time itself. They are describing different paths through space-time, different histories, different sequences of events. And those sequences are shaped by motion and gravity, not by time's intention. Time does not prefer one path over another. It does not push objects forward. It does not guide outcomes. It provides a framework in which outcomes can occur. As this understanding settles, time begins to lose its emotional charge. It no longer feels like something running out. It feels like something holding space. This is not something we usually experience directly because our lives are short and our environments are energetic. But the universe at large is neither short-lived nor energetic in the same way. It is vast, diffuse, patient, and time reflects that patience. The deeper we look into cosmic history, the more this becomes apparent. Most of the universe's story is not about dramatic transitions. It is about long periods where nothing much changes. These periods are not empty. They are full of structure that simply does not need to transform. And this brings us to an important realization. Change is not the default state of reality. Stability is. Change occurs when conditions allow it. Stability persists when they don't. Time does not demand change. It merely records it. So when we talk about time passing, we are really talking about processes unfolding within a stable framework. And that framework, time itself, does not rush. It does not age. It does not approach an end. It simply remains available for events to occur within it. This is why, on cosmic scales, the idea of time running out loses meaning. Stars do not hurry because time is short. Galaxies do not evolve because time is pushing them. They respond only to local conditions, and time accommodates their responses without judgment. As we continue, we'll look at what happens when time is stretched so far that it begins to resemble stillness, not metaphorical stillness, but physical stillness, states where change becomes so rare that time almost disappears from experience, not because it has ended, but because nothing requires it to be noticed. As time stretches further, there comes a point where change itself becomes uncommon, not impossible, not forbidden, simply unlikely. This is not because the universe is slowing down in a literal sense, but because the conditions that allow change become harder to meet. Early in cosmic history, energy was concentrated. Matter was dense. Differences were sharp. Under those conditions, change happened easily. Small imbalances grew quickly. Structures formed. New states emerged in rapid succession. But as the universe expanded, those concentrations softened. Energy spread out. Matter thinned. Gradients relaxed. And as they did, the pace of change shifted. Not because time altered its nature, but because the universe became better at maintaining balance than disrupting it. This is one of the least intuitive ideas in physics. We tend to think of the universe as dynamic by default, as though motion and transformation are its natural states. But on large scales, the opposite appears to be true. The universe seems to prefer configurations that last once a system finds a state that does not require constant adjustment. It tends to remain there. Stars demonstrate this clearly. Their longest phases are not the ones where they are changing most visibly. They are the ones where almost nothing happens. Fusion proceeds steadily. Structure holds. Output remains consistent. These phases last, not because the star is stuck, but because there is no pressure forcing it to change. The same principle applies. Across the cosmos, galaxies, once formed, maintain their overall structure for billions of years. Planetary systems, once settled, persist with remarkable regularity. Even space-time itself, once expanded beyond its early turbulence, behaves smoothly and predictably. This does not mean the universe is static. Local change continues. Stars form in some regions, others fade. But when we widen our view far enough, those changes become sparse. They are no longer the defining feature. What defines the universe at large is endurance. This endurance has a profound effect on how time is experienced, or rather, how it ceases to be experienced at all. Time is only noticeable when something changes. If nothing changes, time leaves no trace. A perfectly stable system contains no internal markers of duration. From the inside, nothing distinguishes one moment from the next. This does not mean time has stopped. It means it has become unobservable. This idea appears again and again in modern physics. In regions where processes slow dramatically, time stretches. In regions of extreme stability, time almost disappears from description. This is not philosophical speculation. It is a practical consequence of how time is defined. Time is measured by change. Remove change, and time loses its operational meaning. This is why the far future of the universe is often described in quiet terms, not because it is empty, but because it is stable. Structures that survive into those eras do so precisely because they do not need to change. They have reached configurations that require no further rearrangement. From our perspective, this can feel unsettling. We associate meaning with motion, with development, with progression. But physics does not assign meaning that way. It assigns likelihood, and stable states are overwhelmingly likely. This is why, when physicists model the universe across extreme timescales, they often find long plateaus, periods where nothing dramatic occurs. These plateaus are not failures of imagination. They are predictions of structure. The universe is not designed to keep producing novelty. It is designed to obey rules, and those rules favor balance over disruption. This does not eliminate the possibility of change. It makes change selective, rare, context-dependent, and as time continues, rarity becomes more pronounced, not because time itself is running out, but because the universe has fewer opportunities to rearrange itself. This is why the question, what happens next, becomes less useful. When we look far enough ahead, what happens next may be nothing at all for a very long time, and that nothing is not emptiness. It is persistence without urgency, a state where time continues to exist, but has little work to do. As we move forward, we'll explore how this perspective reshapes some of our deepest assumptions about beginnings, about endings, and about whether time itself needs to lead anywhere. For now, it's enough to notice this. The universe does not rush, and neither does time. They wait, not in anticipation, but in balance. When we speak about time, we often imagine it leading somewhere, toward a future, toward an outcome, toward a moment when something finally resolves. This way of thinking feels natural because human lives are shaped by destinations. We plan, we anticipate, we measure progress, but the universe does not share this habit. In physics, time does not point toward a goal. It does not accumulate meaning as it passes. It does not build toward a conclusion. It simply allows sequences to exist. This distinction becomes clearer when we examine how physical laws treat the future. The equations that describe motion, gravity, and fields do not contain instructions about what should happen next. They describe relationships. Given a state, they tell us how it can evolve. They do not tell us why it must. This means the future is not a destination. That time is moving toward. It is a range of possibilities that remain available as long as conditions permit. When conditions are energetic and uneven, many possibilities exist. Change is frequent. Events occur. But when conditions become stable, possibilities narrow. Not because time is exhausted, but because fewer rearrangements are likely. This is why the universe appears to slow down as it ages. It is not losing time. It is losing opportunities for change. Time continues to exist, but it no longer needs to announce itself. This challenges a deeply rooted assumption that time's purpose is to move things forward. In reality, time has no purpose. It has structure, and structure does not imply direction. A road has direction because it was built for travel. Space-time has direction only where change reveals one. Remove change, and direction fades. This does not mean the future disappears. It means the distinction between future and present becomes less relevant. In a perfectly stable system, every moment resembles every other. There is no internal clock. That marks progress. From the inside, such a system does not feel like it is going anywhere. From the outside, it continues indefinitely. This is not a hypothetical scenario. It is the expected outcome for much of the universe. As matter spreads and energy evens out, more regions enter long-lasting states. Where little changes, time remains available but unused, like a calendar, with no events scheduled. This is why asking, "Where is time going?" may not be the right question. A better one might be, "What is still changing?" Where change exists, time is visible. Where change is rare, time recedes into the background. And this reveals something subtle. Time does not define reality. Change does. Time is the way we describe how change unfolds. Without change, time loses its narrative role. It becomes a silent dimension that holds events in relation without requiring them to progress. This perspective dissolves the idea that time must lead to something. There is no cosmic deadline, no final moment toward which everything is moving. There is only ongoing availability. Moments exist because conditions allow them. When conditions no longer support new events, moments continue to exist without distinction. This does not imply stasis everywhere. Local processes continue. Stars may still form in isolated regions. Quantum fluctuations still occur. Fields still exist. But the overall character of time changes. It becomes less about sequence and more about coexistence. Events are not replaced by new ones. They are joined by them. Past events do not vanish. Future events are not pulled into being. All events simply occupy their places within space-time. From this view, time does not carry reality forward. Reality occupies time. This is a profound shift, and one that feels unfamiliar, because it removes urgency. Without urgency, many of our instincts fall quiet. We no longer need to ask, "What comes next?" We can ask, "What remains?" And in physics, what remains often matters more than what happens briefly. The universe is built from what persists. Structures that last define everything else. Stars define galaxies, not because they explode, but because they endure. Space defines motion, not because it changes, but because it holds relationships. Time belongs to this same category. It is not an engine, it is a framework, and frameworks do not rush. They wait, not for something to happen, but because waiting is simply their nature. As we continue, we'll move even deeper into this idea of time as a quiet dimension, not something felt, but something present, not something that pushes, but something that allows. And in doing so, we'll see why the universe can be vast, ancient, and still unfinished, without needing to go anywhere at all. There is a point at which time stops drawing attention to itself, not because it has ended, and not because it has slowed to a halt, but because it has become unnecessary to notice. In everyday experience, time stands out because change is frequent. Moments differ sharply from one another. Events replace events. Expectations give way to outcomes. But as change becomes rare, time fades into the background. It does not disappear. It simply stops announcing itself. This shift is subtle, yet it reshapes how reality feels when viewed at large enough scales. In physics, time becomes visible only when something happens, an interaction, a transition, a difference between states. Remove those differences, and time has no markers. A perfectly stable region of space-time contains no internal evidence of duration. From within it, nothing signals that one moment has passed into the next. This does not violate physics. It follows directly from how time is defined. Time is not something we sense directly. It is inferred from change. And when change thins out, time becomes a quiet dimension, present but unremarkable. This idea can feel unsettling at first because it contrasts so sharply with human experience. For us, time feels pressing. It feels limited. It feels like something that can be wasted or lost. But those feelings arise from scarcity. Human lives are short. Biological systems require constant input. Social systems depend on scheduling and sequence. Remove those constraints, and the emotional weight of time dissolves. The universe is not constrained in this way. It does not operate under deadlines. It does not require progress to justify existence. Most of its structure exists without reference to before or after. Galaxies do not age the way organisms do. They rearrange slowly, sometimes imperceptibly, often maintaining the same overall form. For billions of years, on those time scales, time is not a felt quantity. It is a coordinate, a way of describing where an event sits relative to others. This is why, in modern physics, time often appears interchangeable with space. Not identical, but inseparable. Events are not simply earlier or later. They are here and there, then and now. All of these are coordinates. None of them imply motion on their own. Motion arises only when we compare positions. And in regions where positions change little, motion becomes rare. So does the experience of time. This leads to an important realization. Time does not need to flow for reality to remain coherent. Reality can exist without constantly transitioning. In fact, most of reality does exactly that. It exists quietly, without drama, without narrative. Narrative is something humans impose to make sense of limited experience. Physics does not require it. It requires only consistency. This consistency is what allows space-time to function as a framework. It holds events in relation to one another without forcing them to progress. It does not age. It does not tire. It remains available. When change occurs, time becomes noticeable again. When nothing changes, time recedes. This does not make time less real. It makes it less demanding. In the far future of the universe, this background quality of time is expected to dominate. As energy differences soften, as structures settle into durable configurations, events become increasingly rare, not absent, rare, and rarity is enough to transform how time is experienced. Long spans may pass, with almost nothing to mark them. From a human perspective, this feels like emptiness. From a physical perspective, it is stability. The universe has reached a state that does not require rearrangement. And because it does not require rearrangement, time has little to record. This is not the universe running down in a mechanical sense. It is the universe arriving at a condition where change is no longer favored. Time has not stopped. It has become spacious, open, undemanding, and this brings us back to a quieter way of thinking about time altogether. Perhaps time is not something we move through. Perhaps it is something that holds us while other things move. When motion slows, what remains is not absence, but presence without urgency. The universe does not vanish. When it becomes calm, it remains, and time remains with it. Not as a countdown, not as a force, but as a dimension that no longer needs attention. As we continue to build, we will keep allowing this idea to settle, not to resolve it, not to conclude it, simply to let it exist, the way the universe allows time to exist, quietly, patiently, and without requiring an endpoint. When we stop treating time as something that moves, another idea slowly comes into view. That time may not be best understood as a sequence at all. Instead, it may be better understood as coexistence. In everyday thinking, we imagine moments replacing one another. The present becomes the past. The future arrives, then disappears. This model feels intuitive because it matches how memory works. We remember what has happened. We anticipate what has not. But memory is not a feature of the universe. It is a feature of minds. Physics does not require moments to erase one another. It only requires that events have consistent relationships. From this perspective, the past does not vanish. It simply occupies a different region of space-time than the present. The future does not rush toward us. It already exists as a set of possible configurations that may or may not be realized. This idea is sometimes described as the block universe, not as a claim that everything is fixed, but as a way of saying that space-time contains all events as part of its structure. In this view, time does not carry reality forward. Reality is laid out within time. Events do not replace one another. They coexist at different coordinates. What changes is not their existence, but our position relative to them. We move through space-time, along particular paths, Our experience unfolds sequentially because our motion through time is constrained, but the universe itself does not need to experience that motion. It contains all paths simultaneously. This is not a mystical claim. It is a mathematical one. The equations that describe spacetime do not single out a privileged now. They treat all moments as equally real. The present feels special to us because it is where we are located, not because the universe prefers it. This idea can feel unsettling because it challenges a deeply held assumption that the present is something unique, that it stands apart from everything else. But physics offers no evidence that such a distinction exists at the fundamental level. Instead, it suggests something quieter, that past, present, and future are all parts of the same structure, and that time's role is not to move events along, but to relate them. From this perspective, time does not pass. We pass through time, and even that phrasing may be misleading. What actually happens is that physical processes unfold along particular paths. Within space-time, those paths have length, they have order, but they do not imply motion. Of time itself, time remains still, while processes trace patterns within it. This is why, in relativity, different observers can disagree about which events are simultaneous. There is no universal slice of now cutting across the universe. Each observer defines their own, and yet the underlying structure remains consistent. All events still relate to one another in well-defined ways. This reinforces the idea that time is not a flow, it is a relationship, a way of saying how events are arranged relative to one another. Once we adopt this view, many puzzles about time begin to soften. The anxiety about time running out loses its footing. The concern that moments vanish forever becomes less sharp. Nothing truly disappears. From space-time, events remain where they are. What changes is where we are. This does not mean that everything is predetermined. Possibility still exists. Quantum mechanics introduces uncertainty into which events will occur. But uncertainty does not require time to flow. It requires only that multiple outcomes are compatible with the laws of physics. Time does not select among them. Physical processes do. This coexistence model of time aligns naturally with the calm character of the universe at large. If all moments exist within space-time, there is no need for urgency. Nothing is waiting to be created before it can exist. It either exists as a possibility or as an event already placed within the structure. From this view, the universe does not feel like a story unfolding toward a conclusion. It feels like a landscape, a vast structure where paths can be traced, patterns can be followed, and relationships can be explored. Stories belong to observers moving through that landscape. The landscape itself does not tell stories. It simply is. Time, in this sense, is the dimension that allows this coexistence. It gives events their positions without demanding that they line up into a single narrative. And when we step back far enough, this perspective feels less abstract and more intuitive. Mountains do not rush toward erosion. They coexist with erosion. Stars do not hurry toward stillness. They coexist with change. Moments do not chase one another. They coexist within space-time. The feeling of motion arises because we move, not because time does. This realization does not remove mystery. It reframes it. Instead of asking, "Where is time going?" we can ask, "How are events arranged?" Instead of worrying about time running out, we can notice that time has already made room for everything that happens. And in that room, the universe rests, vast, quiet, and unpressured. As we continue, we'll stay with this idea of coexistence and explore how it reshapes our understanding of change, persistence, and what it means for something to endure. One of the quiet assumptions we often carry is that time requires memory, that for time to exist, something must remember what came before. This feels natural because memory is how time feels personal. We remember earlier moments. We imagine later ones. We measure our lives by what has already happened and what we believe has yet to arrive. But memory is not a requirement of time. It is a requirement of experience. The universe does not remember its past. It does not store moments or recall earlier states. It simply exists in a structure where relationships between events are fixed. Events do not need to be remembered to remain part of space-time. They remain because the structure that contains them remains. This is an important distinction. Memory is an active process. It requires energy, organization, and change. Space-time does not perform this process. It does not archive. It does not retrieve. It holds. From the universe's perspective, nothing has to recall the past. For the past to exist, past events remain where they are, embedded in space-time, independent of whether anything is aware of them. This is why physical laws do not include memory as a fundamental ingredient. They include relationships, distances, intervals, causal connections. Once an event occurs, its place in space-time is defined. Nothing further is required. This reveals something subtle about endurance. When something endures in the universe, it does so without awareness. A mountain does not remember being formed. A star does not remember its ignition. A galaxy does not remember its early turbulence. And yet, all of these things endure. They persist not because they hold on to the past, but because nothing forces them to change. This is the deepest form of stability. Stability that does not depend on effort. Stability that does not require maintenance. Stability that simply follows from the balance of forces. Time accommodates this kind of endurance without comment. It does not record it. It does not highlight it. It simply allows it to remain. This challenges another quiet assumption. That persistence must involve continuity of awareness. In reality, most persistence in the universe is unconscious. Structures last. Without knowing they last. Time continues, without marking its own passage. This is why the universe can be ancient without feeling old. Age is a concept tied to memory and comparison. The universe does not compare its present state to an earlier one. It does not reflect, it does not assess duration. Those actions belong to observers. From a physical standpoint, 1 billion years passing is no different from a second passing. Both are intervals. They differ only in length, not in character. This is difficult to feel intuitively because our lives are short and our awareness is continuous. But when we step outside that scale, the neutrality of time becomes clear. Time does not accumulate weight. It does not grow heavier. As more of it passes, it does not become scarce. As it extends, it remains uniformly available. This is why the far future of the universe does not require memory to exist. Even if no observers remain, time does not vanish. Events that have occurred remain positioned within space-time. Structures that persist continue to persist. Nothing needs to notice them. This leads to a quieter way of thinking about meaning. Meaning, like memory, is an emergent property of experience. It is not embedded in the structure of time. The universe does not assign meaning to duration. It allows duration to exist. This does not diminish human experience. It places it in context. Our sense of time matters because we are temporary. Our memories matter because we change. But the universe does not share these constraints. Its endurance does not require remembrance. It requires only balance. Time provides the space in which that balance can hold. When we consider this, the idea of time as something that must be used wisely begins to soften. The universe does not hurry to make use of time. It allows time to stretch far beyond any particular purpose. This is not waste. It is openness, a framework wide enough to hold all processes without needing to justify them. As change becomes rarer, as structures become more stable, time becomes less eventful. But it does not become empty. It becomes neutral, a dimension that holds relationships without demanding sequence. This neutrality is what allows the universe to persist for unimaginable durations without exhaustion. Nothing is consumed by time. Nothing is worn down by its passage. Only processes that depend on imbalance eventually resolve. What remains without effort, and time remains with it, quietly, without memory, without urgency, and without needing to lead anywhere. There is a quiet assumption woven into how we talk about time. That time must be observed to exist, that without something watching, measuring, or experiencing it, time would lose its meaning. This assumption feels reasonable because observation is how time becomes personal. We notice duration. We feel waiting. We sense the difference between moments. But observation is not a requirement of time. It is a requirement of awareness. The universe does not rely on witnesses to continue unfolding. Stars do not pause when no one is watching. Galaxies do not suspend their motion until observed. Time does not check for attention. It simply remains available. In physics, the existence of time does not depend on measurement. Measurement only reveals relationships that already exist. An event does not need to be recorded. In order to occupy a position in space-time, it simply does. This becomes especially clear when we consider regions of the universe where no observers exist. Vast stretches of space have never contained life, never produced consciousness, never been observed directly, and yet physical processes continue there. Without interruption, particles interact, fields fluctuate, radiation moves. Time does not hesitate. In the absence of witnesses, it does not wait for meaning. This suggests something profound. Time is not an experience first and a structure second. It is a structure first. Experience arises only where conditions allow it. And when experience disappears, the structure remains. This challenges the idea that time somehow belongs to observers. Instead, observers belong to time. They emerge within it, operate inside it, and eventually disappear from it without altering its presence. From this perspective, time is indifferent to awareness, not in a dismissive sense, but in a neutral one. It does not require validation. This neutrality allows the universe to continue for immense durations without reference to meaning or memory, long after stars fade, long after galaxies grow quiet, long after any observers may exist. Time remains part of the framework that holds events in relation. Nothing special needs to happen. For this to be true, there is no final observer whose absence would collapse time. Space-time does not depend on perception. To persist, this idea often feels unsettling because it removes a sense of centrality. It suggests that time does not revolve around experience. But physics has consistently shown that the universe does not center itself on observers. It accommodates them, but it does not require them. Time follows the same pattern. It allows observation without depending on it. This has an interesting implication for how we think about beginnings and endings. We often imagine the beginning of time as something dramatic, a moment that must be witnessed to be meaningful, and we imagine the end of time as something equally significant, a final moment where everything stops. But if time does not require a witness, then neither beginnings nor endings need to be experienced to exist. They are simply boundaries within a larger structure, and boundaries in physics are often less important than what they contain. Time does not need to announce its start. It does not need to mark its finish. It exists wherever space-time exists. And as long as space-time remains coherent, time remains part of it. This is why many physicists are cautious about talking about the end of time, not because it is impossible, but because it may not be meaningful in the way we imagine. Time is not a process that can run out. It is a dimension that can only cease if the structure containing it ceases. And even then, the concept of ceasing becomes difficult to define. This brings us back to the idea of time as background. When events are frequent, time stands out. When events are rare, time blends into the structure of reality. In regions where nothing changes, time does not vanish. It simply stops being noticeable. This does not make those regions empty. It makes them complete. Complete in the sense that nothing is required to change, for them to remain consistent. The universe does not need witnesses to validate its endurance. It does not require awareness to continue existing. Time, as part of its structure, shares this independence. It does not ask to be observed. It does not demand to be felt. It simply holds, and within that holding, everything that has happened and everything that may happen finds its place. When we remove the need for a witness, time becomes quieter still, not absent, just unburdened, a dimension that does not rely on attention to justify its presence. And as we continue, this idea will help us approach one of the final questions that often arises when we talk about time. Not how it moves or how it ends, but why it exists at all. Once time is no longer treated as a force, no longer imagined as something that moves, and no longer tied to observation or memory, a quieter question remains. Not how time behaves, but why it exists. This question is not as straightforward as it first appears. In physics, we are used to asking what things do and how they interact. We are less accustomed to asking why certain structures are present at all. But time invites this question because it feels so fundamental. Everything seems to depend on it. And yet, when we strip time of motion, urgency, and narrative, what remains is surprisingly simple. Time exists because relationships exist. At its most basic level, time is what allows events to be ordered, not in a meaningful sequence, but in a relational one. This happened before that. This lasted longer than that. These two events were separated by a measurable interval. These statements do not require intention. They require only consistency. If the universe contained only a single event, time would be meaningless. There would be nothing to compare. But the universe contains many events spread across space. And once there is more than one event, relationships arise. Time is the dimension that allows those relationships to be described. In this sense, time is not an added feature of reality. It is an inevitable one. As soon as there are multiple events, there must be a way to relate them. Time is that way. This is why time appears in every physical theory. That deals with change, not because time causes change, but because change reveals time. The universe does not need time in order to exist, but once it exists in a way that allows events to differ, time becomes unavoidable. It is the bookkeeping of difference. This perspective removes much of the mystery around why time feels so universal. It is universal because relationships are universal. Every interaction involves a sequence. Every process has duration. Time is the dimension that makes those facts expressible. This also explains why time does not have a preferred direction. At the fundamental level, direction emerges only when conditions allow it. At the deepest scales, time is neutral. It does not favor past or future. It does not point anywhere. It simply provides the structure in which pointing can occur. This neutrality is what allows time to support both dynamic regions and stable ones. Where energy gradients exist, time becomes visible through change. Where balance dominates, time fades into the background. In both cases, time remains present. It does not switch off. It does not need to. Time exists because the universe is not a single, frozen moment. It contains variation, and variation requires relation. Relation requires structure. Time is that structure. Once this is understood, the idea of time having a purpose begins to dissolve. Time does not exist in order to do anything. It does not exist to move the universe forward. It exists because without it, the universe could not be described as having more than one event. This makes time less dramatic than we often imagine, but also more profound. It is not a story device. It is a condition, a quiet condition, that allows complexity, stability, and endurance to coexist. The universe does not ask time to lead it somewhere. It asks time to hold relationships steady, and time does exactly that. It does so without urgency, without awareness, without direction, just presence. This is why time persists, even as change becomes rare. As long as there are events, no matter how infrequent, time has a role. Even if nothing happens for trillions of years, time remains the dimension in which nothing happens. This may feel abstract, but it leads to a surprisingly calming conclusion. Time does not need to be used wisely, in a cosmic sense. It does not need to be managed. It does not need to lead anywhere. It is simply the space in which existence relates to itself. And because of that, time does not run out. It does not approach an end the way resources do. As long as the universe contains structure, time remains part of that structure, quietly, patiently, indifferently. And in that indifference, there is no pressure, only continuity. As we reach this point in our exploration, nothing needs to be resolved. There is no final insight. That closes the subject. Time does not offer closure. It offers capacity. Capacity for events to occur, for structures to persist, and for change to unfold at whatever pace the universe allows. And when change slows, time remains, not as motion, not as force, but as the quiet dimension that makes coexistence possible. There comes a point where nothing more needs to be explained, not because the subject has been exhausted, but because explanation itself becomes unnecessary. Time, once stripped of urgency, motion, direction, and purpose, does not ask to be resolved. It asks only to be allowed. Throughout this journey, we've gently loosened familiar assumptions that time must flow, that it must push things forward, that it must lead somewhere. And in doing so, time has begun to feel less like a force and more like a condition that holds. When change slows, time does not disappear. It becomes spacious, wide enough to contain long periods, where nothing needs to happen. In those spans, the universe does not feel unfinished. It feels complete enough to remain as it is. This is not stillness as absence. It is stillness as balance, a balance that does not require effort to maintain. Most of the universe exists in this state, quietly holding structure, quietly maintaining relationships, quietly allowing duration, without marking it. This is why the universe can be ancient, without feeling worn. Nothing is eroded by time itself. Only imbalances resolve. Only gradients soften. What remains without resistance. From this perspective, time no longer feels like something to race against. It is not something that presses from behind or pulls from ahead. It is something that stays open, available, indifferent to pace, whether change unfolds rapidly or hardly at all. Time accommodates both, without preference. This neutrality is one of time's most remarkable features. It does not reward motion or punish stillness. It does not favor beginnings or endings. It simply allows relationships to exist. When nothing changes, time becomes almost invisible. But invisibility does not mean absence. It means quiet, a quiet so complete that it does not ask for attention. And in that quiet, there is no pressure to conclude, no final moment waiting to arrive, only continuation, without urgency. The universe does not move toward silence. It allows silence. When silence is stable, it does not move toward motion. It allows motion. When motion is possible, time does not decide between these states. It holds them both. And as we rest here, there is nothing more time needs to do. It does not need to explain itself. It does not need to justify its existence. It is already doing exactly what it always has, holding, allowing, remaining. And in that remaining, there is no rush to arrive anywhere else, just the quiet persistence of a universe unconcerned with pace. You don't need to follow time forward from here. You can simply let it remain, just as it always does. There comes a moment when explanation gives way to presence. Not because there is nothing left to say, but because saying more no longer changes understanding. Time, once it has been gently stripped of motion, urgency, direction, and purpose, does not ask to be concluded. It asks to be left open. Throughout this exploration, time has slowly lost the qualities we usually assign to it. It is no longer something that pushes, no longer something that pulls, no longer something that runs forward or slips away. Instead, it has become something quieter, a condition that allows things to exist without demanding that they change. When we imagine time this way, the universe begins to feel less like a process and more like a state that can hold motion when motion is possible and hold stillness when stillness is stable. Most of the universe exists in this second mode, not frozen, not inactive, simply unhurried. Galaxies drift without needing to arrive. Stars persist without needing to transform. Space expands without needing to announce itself. And time remains present throughout it all, without directing any of it. This is one of the quiet truths of modern physics. Time does not instruct the universe what to do. It does not guide events toward outcomes. It does not decide when change should occur or when it should stop. It simply provides the framework within which relationships can exist. When change slows, time does not weaken. It becomes less noticeable, and that distinction matters. Something can be present without being prominent. The night sky does not disappear when clouds pass. The ocean does not vanish when its surface is calm. In the same way, time does not disappear when nothing changes. It becomes background. And background, on cosmic scales, is the dominant condition. This is why the far future of the universe is often described in such gentle terms, not because it is empty, but because it is balanced. Energy differences soften, structures settle, processes that once demanded motion no longer require it, and time remains available even when it has little to record. This does not mean the universe has ended. It means it has arrived at a condition where change is no longer favored. Arrival here does not imply a destination. It implies rest, not rest as cessation, but rest as sufficiency. Nothing is missing, nothing is incomplete. There is simply no pressure to move. From a human perspective, this can feel unfamiliar. We associate meaning with momentum, with progress, with the sense that something must happen next. But the universe does not share this instinct. It does not evaluate its own state. It does not compare one era to another. It does not feel the passage of time. It simply exists within it. Time, in this view, is not something the universe experiences. It is something the universe contains. And because of that, time does not grow heavy as it accumulates. 1 billion years does not weigh more than a single second. They are different intervals, but they carry no burden. This is why time does not wear things down. What changes wears itself out by resolving imbalance. What remains, balanced, remains. Time does not erode mountains. Gravity and weather do. Time does not exhaust stars. Fusion does. Time does not age the universe. Expansion redistributes energy. Time is not responsible for endings. It is simply present when endings occur, and present when they do not. This reframing removes urgency from the idea of time altogether. There is no countdown embedded in reality, no universal clock approaching zero, no moment toward which everything must move. There is only continuation, as long as structure allows it, and structure, on the largest scales, is remarkably resilient. As we rest here, there is nothing that needs to be resolved, no final insight waiting to arrive. Time does not reward understanding. With closure, it offers something quieter, space, room for events to exist or not exist without pressure, room for change to occur when conditions allow, and for stillness to persist when it does not. The universe does not rush to fill time. It allows time to remain open, and in that openness, there is no requirement to move forward, only the quiet endurance of relationships, holding steady. You do not need to follow time beyond this point. You do not need to imagine what comes next. Time will remain, with or without attention, holding, allowing, unconcerned with pace, just as it always has.